learners, welcome to this lesson. This is your teacher Agnes, and today we are going to be discussing about squares and square roots. Squares and square roots. So to begin with, we are going to start with squares, okay? And then we will proceed to square roots. So what is a square? A square is a number that you obtain when you multiply another number by itself. Okay, so if I take 4 times 4, I will obtain 16. So we say that 16 is the square of 4. So a square is the number that you obtain after multiplying a number by itself. So 16 is said to be a square number. Another name for a square number, so we say that this is a square number. Okay, we can also say that this is called a perfect square. A perfect square. So numbers that are obtained through multiplication of other numbers by themselves are known as square numbers or perfect squares. So I want us to try and come up with the first 10 square numbers. And for us to obtain the first 10 square numbers, we will have to multiply the first 10 natural numbers by themselves. So we are going to begin with 1. So if we have 1 times 1, we obtain 1. 2 times 2, we obtain 4. If we have 3 times 3, we obtain 9. 4 times 4, we obtain 16. 5 times 5, we obtain 25. 6 times 6, we obtain 36. 7 times 7, we obtain 49. 8 times 8, we obtain 64. 9 times 9, we obtain 81, and then finally 10 times 10, we obtain 100. So these are the first 10 square numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So I'll challenge you to try and get the next 10 square numbers. If you take 11 times 11, what do you get? So you can proceed like that until you get to the 20th square number, which will be obtained after multiplying 20 by 20. Now, how do we represent a square? A square has a symbol of representation. So instead of writing 1 times 1, this can be written as, instead of writing 1 times 1, we can have 1 squared. So this power 2 here, so this is read as 1 squared or 1 power 2. Okay, if you can see, the 2 is written at the top. So 4, instead of writing this as 2 times 2, we can have this as 2 squared. And the value of 2 squared is 4. The value of 1 squared is 1. Now, if we do the same for all these numbers, we will have 9 is the same as 3 squared. Then 4 times 4 is the same as 4 squared. This is the same as 5 squared. 6 times 6, 6 squared. 7 times 7, 7 squared. 8 times 8, 8 squared. 9 times 9 is 9 squared. Then 10 times 10 is 10 squared. So if you come across a question that maybe requires you to determine 25 squared, this means that you do 25 times 25. That is the meaning of the symbol, which is read as squared. Alright? 25 squared means 25 times 25, which when you multiply, you get 625. So you can say that the square of 25 is 625, or 625 is the square of 25. I hope you are getting those terms, that the square of 25 is 625. An alternative way of saying that is that 625 is the square of 25. Alright? Now, anytime you want to get the square of a number, you just need to multiply that number by itself. It doesn't matter whether the number is a whole number, a fraction, or a decimal. Alright? So if you had something like 0.4 times 0.4, these are two decimals, right? But it's 0.4 times itself. So we need to get the square. So this can be represented as 0.4 squared. So how you do that? You just ignore the decimal places first. So 4 times 4 is 16. But the total number of decimal places is 2. So the answer will be 0.16. So it doesn't matter whether a number is a whole number or a decimal number. If it is a fraction, if you have 2 over 3 squared, okay? 2 over 3 squared means 2 over 3 times 2 over 3. So this will be equal to 2 times 2, which is 4, 3 times 3, which is 9. So the square of 2/3 is 4 over 9. So you can get the square of any number, whether it is a whole number, like these whole numbers, or a decimal number, or a fraction. Now sometimes you have numbers that are either very small or very huge. For instance, if you have a number like 0.00894 and so on, and then you are required to get the square of that number, it can prove to be quite difficult using this method. Therefore, you can use the mathematical tables to determine the square of numbers that have decimals, numbers that are either too big or numbers that are either too small. So next, we are going to look at how do we use the mathematical table to determine the square of a number. Okay, learners, so now we are going to look at the mathematical table and how we can use it to determine the square of numbers. So the mathematical table can be used to find different items, reciprocals, square roots, cube roots, and so on. So today we are going to focus on squares. So when you get a mathematical table, you must make sure that you read the title of the table and ensure that it is written squares. So for squares, we have 2 pages. We have squares of numbers running from 1 all the way to 5.3 plus other decimals. And then we have another page of tables, another page of square tables running from 5.4 all the way to 9.9 and other decimal numbers. So this tells you that you can only read the square of a number that is between 1 and 9.999. Yes. So if you have a number that is less than 1 or a number that is greater than 9.99, we will be discussing how you determine the square of that number using the tables. Now, after the X column, which shows you the number that comes before the decimal point, we have other 9 columns which represent the second decimal point. Okay? So if you have a number like 1.03, then this third column represents the value when you have up to the second decimal point, and the second decimal point being 3. Then here we have other columns that also run from 1 to 9, and they represent the third decimal place. So when we start looking at an example, this is going to be very easy for you to understand. It is important that you notice that when dealing with squares, this column here, when taking any value from these columns, we add. I'll show you how we add. This is important for you to note because in some other tables, you are required to subtract. So always make sure that you are keen of what is written here. So in this case, you're supposed to add. Now to begin with, we are going to start by getting the square of a number that is very familiar. We have just said that if you take any of the natural numbers and multiply it by itself, you will get the square of that number. For instance, if you take 4, you multiply by 4, you get 16. So 16 is the square of 4. So 4 squared can be written as 16. Now I want us to try and get the square of 4 using the tables. So 4 is between 1 and 9.99. So it is possible for us to get the square of 4 from the tables. So to do that, we will come to the tables and check the column X, then trace 4. Okay? So in this column of X, we are going to trace 4. Here we have our 4. So this is 4.0. So we're going to read in the column that shows 0 above here. So this is like 4.00. That is the same as 4. So according to this, the value of the square of 4 is 16.000. But we know that these 3 zeros are not significant. Therefore, we can say that from the table, the square of 4 is given as 16.00, which is the same as 16. So now we have certified that the table is actually accurate. So what happens if you have 4.1? So if you have 4.1, then we will come, we still from the table, along the column of X, we will trace 4.1. So this is 4.1. So according to this, 4.1, the square of 4.1 is a value given here, which is 16.810. So the square of 4.1 will be equal to 16.810. Now let us upgrade to a number that has more than one decimal place, a number like 3.65. So how do we read 3.65? The square of 3.65. So we are going to determine the square of 3.65. So you notice that here now we have 2 decimal places. So we are going to start by tracing 3.6 on the table. So along the column of X, we are going to trace 3.6, here it is, then 3.65. So now, in these other 9 columns, we will look for 5, okay? And then check where that coincides with 3.6. So that gets us to 13.322. So this is 3.6, then the 5th column. So this gives us the square of 3.65 to be equal to 13.322. Okay, now this is when you have 2 decimal places. What if you have 3 decimal places? So if you have a number like 7.136, how do we determine the square of 7.136? So we start by tracing 7.1 along the column of X. So if you check in the first page of squares, the last number that you can get to is 5.3. So we have to check in the next page. So if you check in the next page, you will be able to get 7.1. But we need 7.136. So 7.1, then we check in these other 9 columns. The third column gives us 50.84. So if you coincide 7.1 and the third column, we get to 50.84. So you will need to put this down first, 50.84. Now remember, this is up to 7.13. So what about the 6? So for the 6, we check in the other 9 columns that say add. And in this case, we are going to concentrate on the 6th column. So this is the 6th column. We are going to coincide with the 7.1. So this gives us 9. So this means that we are supposed to add 9 to the value that we have already obtained. So we add 9 and we add it on the side of the decimal places, not on the side of the whole numbers. So we add 9 here, so that 4 plus 9 becomes 13. So 3, we carry 1. 1 plus 8 is 9. Then 0, and then 5. So the square of 7.136 is 50.93. Alright, our final answer will be 50.93. So now we started with a number that did not have decimal places, proceeded to a number with 1 decimal place, then a number with 2 decimal places, and then a number with 3 decimal places. Now, what if you have a number with 4 decimal places? If you have a number like 8.0175, okay? So this is 1, 2, 3, 4 decimal places. But how many significant figures are these? 1, 2, 3, 4, 5. Now, if you read the title of your mathematical table, you will notice that it is called a 4-figure mathematical table, meaning that you can only read values or squares of numbers that are up to 4 significant figures. So even before we proceed to use the square tables, we have to write this number correct to 4 significant figures. So we start counting from 8, 1, 2, 3, 4, slash at that point, then check the next number. If it is 5 or more than 5, then we add 1 to the 7. If it is less than 5, then we just drop it. So in this case, we have 5, so we have to add 1 to 7. So our new number now will be 8.018. So this is the number that we are going to use and check its square, right? So the point here is, if you have a number that has more than 4 significant figures, then you need to first write it correct to 4 significant figures, then determine its square using the tables. So in this case now, we are going to look for 8.0 along the x column. So along the x column, we're going to look for 8.0. This is 8.0, and then the next number is 1, so 8.01. So the next column is the column of 1, okay? This is the column of 1, gives us 64.16. And then the next column is the column of 8. So we are supposed to add 13 to 64.16. Alright, so this 64.16, we add 13. So this will be equal to 64.16, and then we add 13. So 6 plus 3 is 9, 1 plus 1 is 2, then we drop the 4 and the 6. So the square of 8.018 will be equal to 64.29. So that is how you determine the square of numbers when the numbers are ranging from 1 to 9.99. So next, we are going to look at, if you have a number that is less than 1, how do you determine its square using the tables? In a case where you have a number that is less than 0, a number like 0.0 0.0482. So you realize that we don't have 0.0 in the x column. We only have from 1.0 to 9.9. So we cannot read this directly from the square tables. So what do we do now? We will have to write this number in standard form, meaning we will have to move the decimal point from here to be in between the first two digits, the first two non-zero digits. So we have to move the decimal point from here all the way to between 4 and 8. So when we write this number in standard form, we will have 4.82. Then because we have moved forward twice, we multiply by 10 power negative 2. So we already learned how to write numbers in standard form. So I want to believe that you can recall that. So you move the decimal point to between the first two non-zero digits, in this case 4 and 8. And then, since we have moved the decimal point forward twice, then we multiply by 10 power negative 2. So now, we needed the square of 0.0482. Now we are going to determine the square of 4.82 times 10 power negative 2. So this means that you are going to get the square of 4.82 first, then get the square of 10 power negative 2. Alright? We get the square of 4.82 from the tables, and then I'll be explaining how we get the square of 10 power negative 2. So from the table, 4.82, we look for 4.8 along the x column. So here we have 4.8, we need 4.82. So along the second column, we will get 23.232. So the square of 4.82 is equal to 23.232. Now we are going to get the square of 10 power negative 2. Now for us to understand what happens here, we will have to rewrite 10 power negative 2 in the fraction form. So to begin with, 10 power 2 is the same as 10 squared, right? 10 squared, which is 10 times 10, which is equal to 100. Now 10 power negative 2 is the same as 1 over 10 squared, which is equal to 1 over 10, right, times 10, which is equal to 1 over 100. So 10 power negative 2 is the same as 1 over 100. So you notice that this is 2, and here we have 2 zeros in the 100. Then because it's a negative in the power, that's why we are having a fraction, right? Now if we square 1 over 100, 1 over 100 squared, remember we squared a fraction during the introduction. This is the same as 1 over 100 times 1 over 100. If you multiply, you will obtain 1 over 10,000. Now, 10,000 can be written to the power, in form of power, that is to the power of 10. So 10,000 has got how many zeros? 1, 2, 3, 4. So this is the same as 1 over 10 power 4. Alright? So you realize that the square of 10 power 2 is equal to 10 power 4. So if we write this in a way that we don't have a fraction, we will have to introduce a negative to the power. So this will be 10 power negative 4. So the square of 10 power negative 2 is equal to 10 power negative 4. Now in a simpler way, this negative 4 can be obtained by multiplying this negative 2 by the 2 to get negative 4. So if you have 10 power negative 1 squared, you will just need to multiply negative 1 by 2 to get negative 2, so that now the square here will be 10 power negative 2. If you have 10 power negative 3 squared. Then this will be 10. Negative 3 times 2 is negative 6. So I hope now we have gotten the concept of squaring a power. Now this is not only the case. Like this case applies even when the power is positive. So if you have 10 power 2 squared, you will just need to multiply 2 by 2 to obtain 10 power 4. If you have 10 power 4 squared, you will just multiply 4 by 2 to obtain 10 power 8. So now that we have understood this concept, if we refer back to our question where we have 10 power negative 2 squared, this will be 10. Negative 2 times 2 is negative 4. So this will be 23.232 times 10 power negative 4. So for us to write this number back to number form, this is the standard form, we can write it back to number form. Now since you're multiplying by 10 power negative 4, this means that we move the decimal point backwards 4 times, alright? So 1, 2, 3, 4. So these two spaces will be filled by 0. So the answer will be 0.00232. So this is now the square of 0.0482. Alright? So that is how you determine the square of a number that is less than 1. So let us look at one example that we are going to do directly, because I want to believe now we have remembered how to write a number in standard form and we have understood how to get the square of a power. For example 2, we are going to determine the square of 0.00537. Alright, 0.00537. Now in this case, we cannot read this directly from the tables because it is 0.0. You can only read from 1.0 to 9.9. So we need to write this number in standard form. So we will move the decimal point so that it is in between the first two non-zero digits. So this is 5.37 times 10 power negative 3. Remember, we want to determine the square of this number. So we are going to start by reading the square of 5.37 from the tables. So 5.37, so we trace 5.3 in the x column. This is 5.37, so this is the 7th column, so this reads as 28.837. So the square of 5.37 is 28.837. Then you multiply by 10 power. So you want to get the square of 10 power negative 3. So like we have discussed, we will just multiply negative 3 by 2, which is equal to negative 6. Alright? Now if we need to write this back in number form, we will now move the decimal point backwards 6 times. So since we already have 2 digits here, we need to add another 4 zeros so that we will have moved the decimal point backwards 6 times. So this will be equal to 0.0002837. And that is how you determine the square of a number that is less than 0. Now in some instances, you will be needed to perform other operations such as addition and subtraction involving squares of numbers. Now if you have a number that is greater than 9.9, then you use the same rules as a number that is less than 1. So if you have a number like 44.63, okay, you cannot read 44.6 in the square tables, but you can read 4.4. So you will have to write this number in standard form which is going to be equal to, so we are looking for the square of this. So we move the decimal point backwards one step. So this is 4.463 times 10 power 1, because we have moved backwards once. So you're going to determine the square of this. Now, we're going to read the square of 4.463 from the tables. So we first trace 4.4, then the column that coincides with 6, this is it, and then the column that coincides with 3, which has 27. So now you're going to add 27 to 19.892. So this will be 19.892, and then we add 27. So on adding here we have 9 plus 2 is 11, 1 carry 1, then 1 plus 8 is 9, then is 9, and then the 1. So the final answer for the square of 44.63 will be 19.919. Then we multiply by 10 power 1 squared. So we say that if you want to square power, you just multiply it by 2. So this will be 10 power 2. So writing this in number form, again, we will have to move the decimal point forward 2 times, because we are multiplying by 10 power positive 2. So moving the decimal point forward twice, we will have 1991.9, and that will be your final answer. Now, in some questions, you are required to perform other operations such as addition and subtraction when dealing with squares. So you might have a question like 4.61 squared plus 0.28 squared. So you realize that here now you cannot add squares directly. So what you will have to do is that you will have to determine the square of 4.61, then determine the square of 0.28, and then add the 2. So 4.61 squared will be equal to, from the tables, 4.61, okay, the column of 1. So this is 21.252. And then we determine the square of 0.28. Now we cannot get the square of 0.28 directly, so we have to write 0.28 in standard form first. So this will be 2.8 times 10 power negative 1, because the decimal point will move forward once, and then we square this. So now we get the square of 2.8. So this is 2.8 along the x column, 2.8, which reads 7.840. So the square will be 7.840 times 10. Now the power negative 1 times 2, which is negative 2, meaning that we move the decimal point backwards twice to obtain the number. So this will be 0.0784. Now since we have the square of 4.61 and the square of 0.28, we can now add them as the question required. So now we will have 21.252 plus 0.0784. So we add a 0 here. So 0 plus 4 is 4, 2 plus 8 is 10, 0 carry 1. 1 plus 6 is 1 plus 5 is 6, 6 plus 7 is 13, then 1 plus 2 is 3, then 1 plus 0 is 1, then we have 2. So the final answer, which is the sum of the two squares, will be 21.3304. So that is all you need to know about finding the square of numbers, whether mentally or whether using a mathematical table. So now I'm going to give you a few questions that you are going to attempt as your exercise. Now you're going to determine the square of these numbers. So use tables to find number 1, the square of 5.5, then the square of 0.0681, then finally the square of 428.7. So that is all about this lesson. Thank you so much for being in this lesson. See you in the next lesson.